So today I'm gonna try to rebuild PixiJS from scratch or from the beginning. And it's probably gonna take me several days to do this. And I'm not sure if I'm gonna follow through. Depending on how hard it is to rebuild it, I might decide to just use PixiJS and not rebuild, but I think it's very likely that I'm gonna try to rebuild everything and do my own thing. And I managed to figure out the zoom and the panning and to make it work, which I'm very happy about. And yeah, but I'm not gonna show this now. I think maybe some other time. So I think I'm gonna put music and then hopefully they don't take down the stream. If they do, I'll just restart. So I'm gonna put the timer for probably 2 hours, then I'll take a break. Let's see if I will continue in 2 hours or do it off stream. I think the first thing that I'm gonna do is just download the PixiJS locally here, and then go over with the debugger, see what systems are being used in the beginning, and then just get all the files from the systems and put them on a folder. I think I'm gonna follow this. I'm obviously gonna watch a lot more of these videos off stream, but I just have the code here, which he shares on the repository. And I think I'm gonna download some of these lessons here. And I'm also gonna try to do that because, yeah, I think the best thing is probably to get the systems from PixiJS, put them all of the systems on a file. I think the hardest part is gonna be to figure out how they do. I don't think I'm gonna figure out how they do the management of the context. Just select the context based on the browser that the person has. I think I'm just gonna do something simple to default to the normal canvas in case they don't have the WebGL, or just leave with the WebGL, and then people that don't have WebGL can't use the site, because I think that nowadays most browsers have WebGL, I think. So I'm just gonna get the systems, and what I'm gonna try to do is on the other project, which is the learning folder here, I'm going to try to initialize everything from scratch, following the code from the other tutorials, and then try to slowly move to the Pixie, because I spent a lot of time studying them and trying to understand how they do things, but I didn't look into the nuances of it. And there's some stuff as well that I realized that I forgot to talk about, which is the main thing that I was talking about this, that I wanted to talk about, but I think maybe later I'll say it, because there was so many things on my mind that I forgot to say the most essential thing. But it's pretty much that there's two different paradigms. One is cold approaching women and like going on the streets and trying to pick up women. That's a waste of energy, it's not efficient. And that would be like code selling people, like trying to advertise your YouTube channel on other YouTube channels and stuff like that, which people back in the day used to do a lot, but it's very inefficient and it's just annoying. So it's not an optimal strategy, I think. It's much better to try to focus on building first and growing and attracting. And I think it's the same with jobs as well, that you need to strike the balance. If you don't send off the offers, or don't try to get offers from anyone, then like no one knows about you. It doesn't matter how good you are. But at the same time, if you're focusing all your energy into trying to get a job, it's very inefficient because you don't have a lot of power. So it's much better to focus on building yourself first and becoming better, and that's gonna exponentially increase your odds of finding someone. or being accepted to a job. So that's what the way that I think is best to think about it. It's like focusing on attracting first instead of chasing. I think most people focus on chasing because they are focused on the result, because it's easier to focus on the result because it's transparent. You can see it. So it's much harder to focus on the process, which is the thing that creates the result. And it's like playing poker, where the reason why most people lose is because they are focusing on whether or not they are winning at the moment, but they are not focusing on the fundamental strategy that creates the results. The whole challenge of the game of poker and the business and everything in life, I think, is creating the connection between the strategy and the results, and becoming better and better of identifying if you are applying the correct strategy or not, and if you're not, what are the reasons why you're not, and then trying to recalibrate over time, which is very difficult to do because the variance is very high. That's pretty much what I forgot to say. So I wrote down this, I create this flow chart here, and I didn't analyze because there's so many systems and so many loops. I didn't go over all the loops and what happens when the context change is triggered. So I think that's what I'm gonna do now. When you see exactly what happens inside of the systems in these functions of the context change and what they do with the canvas, because I want to understand exactly how PixiJS is how their API works to communicate with the WebGL, which is the stuff that is going to draw. So you have to create a program, and the program is made up out of vertex and fragments, like fragments and shaders, I think. One is related to the position and the other related to the colors, and the GPU draws everything in triangles. And then you create a program that it is built on the JSLS, I think, language, which is the language that communicates directly with the buffer, which is the stuff that is gonna run inside of the GPU. And then you use JavaScript to create the code based on that. And I think that they do string formatting, where they do a bunch of functions that have the strings that are gonna contain the parts of the program that create the variables. So it's pretty much a JavaScript API to construct GSL code with strings. So I want to understand how they do that, and try to rebuild it. Let's see if I can add Pixie here. I just PixiJS, I think. Maybe it's just easier to go to the other project that I have and just step through that project. I think that's what I'm gonna do. Because it's kind of annoying to set things up when you don't have when you don't initialize things with a framework. And it's different the way that you have to put stuff there. So I think I'm just gonna get the code from the beginning lessons of the videos, so I don't have to set the stuff up, and then I just have the beginning ground. But I didn't like very much the way that he does things there, because he puts JavaScript code in here using the script tag. So I think I'm just gonna copy that stuff and put on another file. And then here I'm gonna grab this. So I'm gonna open the other project, and then I'm gonna step through the code of the other project, and I'm gonna see what systems is using and where are the systems located in the files. And I'm gonna go here, grab the files, and put on another folder in here. Or maybe it's easier if I do it like this. And I think what I'm gonna do is so there's two main things that I have to do still. One is this thing where I'm trying to recreate PixiJS from scratch, so I understand a lot better how it works, how it actually does the drawings. And the other fundamental thing is to create a component that is gonna contain the customization for the graphs based on the data. I think those are the two main things that I have to finish. And then I think after I finish that, and also I'm gonna probably reconstruct the CSS from the site and make the front page and add the like the bullshit that is needed, like the about section and the footer and things like that, that are kind of annoying to do it, but easier. So once I have all of this stuff done, then I think what I'm gonna do is just switch the frameworks. I'm using Next.js now, so I think I'm gonna continue with the other project that is just using Vite. And I think the reason why is because I think that the trend for Next.js is to be more and more focused on Vercel. But I'm not 100% sure about that, but I think that there is a risk that that happens over time. And I don't like the... I don't know for sure because I didn't research these things, but I don't like the idea of being trapped by a framework, of building everything on top of that, and then realizing later on I can't switch for anything else, I don't have flexibility. So I think Vite is harder to begin because you have to deal with more stuff, like the routing and the other stuff. And there's nice things about Next.js, but I think it's better to just continue with Vite, and then I have more flexibility. So what I'm gonna do is just have to figure out how to redeploy everything, change the repositories on, which I think what I'm gonna do is just pass the Git file to the other folder, and then recommit everything. And then I'm just gonna change the configuration on Vercel to deploy using Vite instead of Next.js. Which hopefully is not that hard to do. And I don't have a strong opinion about all of this stuff. I don't have a lot of knowledge. It's just the easier thing to do, I think. I don't want to think about this stuff, so I think it's better to maintain flexibility. And then later on, the more I study and the better I become, I can just build stuff on top of it. And there's also another framework that I saw that I was thinking about switching, but then I decided otherwise, which is Solid.js, which is pretty much the same thing as React, but the only difference is that it only runs the components once, and that fundamentally changes the way you have to structure things because of there's a difference in reactivity. But it's very similar to React and it seems to be faster, but I'm not really sure if it's worth it to switch, because then the problem with that is that if I switch to another completely new framework, then I'm gonna be thinking about other frameworks, and then I'm just gonna keep switching, and I'm not gonna focus on the main thing, which is building the application. So, but it also seems like React is approaching the end of the cycle, and then it's very likely that there are gonna be new frameworks that learn from the stuff that React did and do it better. And then it's just gonna keep growing like that. So maybe at some point, eventually, I'm gonna have to switch. But I think that's not a problem, because when that time comes, then I think about it. But for now, I think it's better to just focus on the fundamental stuff here. And I thought about a concept which I think at some point would be interesting to implement. Or maybe someone could implement as well, but I find it difficult that someone will. But the idea would be to use Lagrange interpolation to manage state. Because everything is a cycle, and then it becomes a hierarchy through the DOM. So that's the fundamental essence of the thing, and I think Lagrange interpolation is probably going to be useful to synchronize the states of the DOM, because everything is a cycle. So when you perform Lagrange, you can use transfer transform to make the cycle a wave function, and then you synchronize that with Lagrange interpolation, and that should probably optimize the state. But I'm not really sure about that, because I learned about these things fairly recently. So maybe it's just when you learn about a new tool, everything, when you have a hammer, everything seems like a nail. So it might be that's going on with me after learning about these things. I just see it everywhere now. So obviously there's a container, so maybe we should go and grab the container and then display object. I think that, so this paradigm, I'm not really sure what the name is, but it's like, I think it's object-oriented programming, but it's like the display object is an abstract class, which is pretty much a template. And then from that template, all the other classes are created, I think, to draw this stuff. So I think that the beginning is more general, and it's similar to everything else, where it's going to create a hierarchy, where the base class is going to be more general, and it's going to contain like the fundamental structure of the thing. And then the more specific the stuff you want to draw is, the more custom methods are added, I think. And I think that is an exemplification of the way that space-time works as well, where you have a hierarchy, a pyramid. So the base class is the base of the hierarchy. And then the flow of space-time is going to determine how the hierarchy evolves into a multifractal structure that's going to represent the stuff that they were trying to build. Next to display. I think it's easier to just send it through here. And the problem is that there are multiple. I think I'll just get all of them. I think all of these different extensions is because of the way that JavaScript works. That are multiple different imports you can do, which is another annoying thing. And this is something interesting to think about as well, because I think it's one of probably the biggest challenges as well we have, that because you don't know how things are going to be when you begin something, you just find the best solution you can at the time. That generates gravitational force, which becomes bureaucracy, and that's why big companies fail, I think, or they go bankrupt, because the more you build on top of that, the more mass and gravitational force you have around something that may not be optimal. And that's the reason why other frameworks and other stuff is created to make up for that. But then it's like you're creating duct tape solutions for this stuff and not fixing the fundamental problem. And the issue is because you build all the structure on top of this thing, so it becomes harder and harder to reconstruct everything, because everything's connected to the stuff you had in the beginning. So the challenge is, how do you create something where it breaks the cycle because it's new, but at the same time it's efficient in changing everything else that was built before. And that's a very hard thing to think about. Because obviously it's going to be resistance, because that's the nature of the limbic system, and probably the nature of computation as well. Because of mass and momentum, people don't want to change their habits, because their habits are connected with space-time, and that's what kept them alive for a long time. So there's risk in changing. So it takes more force and power to change the structure, which is directly correlated with how much mass this structure has, how much information it has behind it. I think this bounds is used in one of the classes as well. I think the bounds are the limits of the camera. So if I remember correctly, the class is initialized as infinite, so minus infinity and plus infinity for the how big is going to be the projection of the world of view. And then you also have the transform class, and I think the transform class is the stuff that is responsible for calculating the world model and how the elements are going to change in the screen, and the camera and stuff like that. Obviously I don't know anything yet very well yet. XMF lib. Not sure. The matrix is going to be used as well. There's a bunch of matrix calculations. Yeah, maybe I should separate them. I think I'm gonna put all of this here, which is related to visualization. And then I'm gonna create a folder here to visualization, and then the other folder is gonna be systems, which are the main systems that organize everything. So the way that it works is that it has core systems, and then it has runners, which are a class that represents a function inside of the systems. And then when you call the emit function of the runners, it's just gonna call the function for all the systems that have the function. So I have to see if I can figure out what classes are the ones creating the stuff that is gonna communicate directly with the WebGL canvas. The point is also part. So observable points and points. And point is used on the event system. I'm not sure if it's this, so maybe I'll wait until I get to the point, to that part. Oh, it's this one probably. Points. And transform. And I think the main reason, that's the other thing that they do, which I'm doing as well, because I copied their code for some extent in the wheel function. They customize the events and they add certain attributes to the event so that you can communicate with the other parts of the whole, all of the classes that handle the visualization. So there's several functions that allow you to just grab the relative coordinates based on the whatever's happening on the transform, which handles the world view. But I think outside of that, it's not that useful to have the custom events, and I think it adds a lot of complexity and makes things more confusing. So it's gonna be annoying, but I think I'm probably gonna have to, or maybe I'll just copy the functions. I think that's what I'm gonna just copy the functions, and then just leave extract. Get those functions out of the systems, and I'm not gonna use the custom events. And that way, I think it's gonna be a lot easier to understand what's going on. My goal is to try to simplify the complexity as much as possible. To just the stuff that I wanna use. And I think that's the evolution of information as well. It's like the fractal spiral pattern, where in the beginning you do nothing, and then it becomes more and more complex. Because it's the whole stuff about the duct tape I was talking about, where it generates gravitational force because you don't know. By definition, you don't know how to do something before you start. So you're gonna implement solutions that are suboptimal, and that's gonna generate gravitational force, which is gonna create information in the system. And then after you learn everything by going through the whole process, then the second half, I think, is thinking about how to simplify everything, and then how to change all of the stuff that was built before, so that is more simplified and that optimizes the way things are. But that's very hard to do. A matrix, I think I already got. Maybe I should just move the flip matrix. I think I made a mistake there. Because I should just move the classes as I see them here. Like, so I make sure that I'm getting the exact files that is using here. Matrix MJS. Matrix MJS. Matrix MJS. I just map, so probably already got it. I think I already got this one as well. Yeah. The bounds is the one that I talked about before. The infinity minus infinity. Pixie display leave bounds. And I think, oh, so here, maybe I should grab this one as well. Is the one being used. I think probably today I'm just gonna do this because it's gonna take a lot of time. I'm gonna have to step into all of these functions that are on a loop. It's quite annoying because I have to see what happens when they call the function. I think this one is not necessary to, because it's just gonna build the runners, and each runner is gonna have inside of it is gonna have a list of items, which are the list of systems. But it's not important to know all of the runners. I think it's just they're just functions on the classes. But I think this one I'm gonna have to step over all of them. I should look maybe on the next loop. I could just go on the other class and then see. Maybe I'll open here. Because I just gonna grab the names of everything that's used. And that way, if I don't have the patience to step into each one, I just grab by the names. Just copy everything. Also, the systems are here. I think the priority is gonna be the name inside of the class. And this is annoying. Maybe I have this at in some file. Because I remember doing this for doing the oh yeah, I think I have on the Skyly Draw thing. Yeah, I have on the Skyly Draw. I already did this. These are the ones. So I think these orders are gonna be mapped here. Instead of the class, so it's gonna create an attribute in the systems that are gonna have the name of this. So it's gonna be this, and the whatever is here, and it's gonna be equal to the classes here, which are the systems, I think. And it calls the init. Yeah, the main thing that I don't know yet is exactly what happens on the actual canvas. What is the direct connection of the API? It's both that and the render loop, which is confusing because of the way that they do the ticker. I think it's confusing, but it's probably the correct way to do it, where you use a linked list to create the cycle of the animation. I don't know very well how it works, but I think that it probably would make sense to have it like a circular linked list, and then you just keep some whatever amount you want of different frames, let's say, in the cycle. So the size of this, you can choose the size of the cycle by choosing how much nodes are connected, and then you just go over in cycles between them, because that way you can store the state of any frames you want by managing or deciding what is going to be the size of the cycle. So if you want to keep track of 5 frames, you have a linked list with 5 nodes that are connected through a cycle, and then you just switch for each node every time it runs the function. That way allows you to access what happened in the last 5 frames. But I'm not exactly sure if that's how they do it, or if it's more a double buffering technique where one of the nodes contains the state and the other node is the one that is gonna be updated, and then you update the new node and then you switch the one with the one that had the state before. Not really sure how it works really well. Yeah, the runners and stuff I'm gonna skip. I think I'm gonna go over one by one to see if there's any of them which probably there is, that creates something. I remember that there are some classes that create a state which contains a program, and I think that the program is going to be the thing that communicates with WebGL. So I have to find which ones are the ones. Maybe I'll do it with the Skyly Draw here. I think I'm going to copy this stuff, and then I'm going to do it somewhere else, so I don't fuck up this other flowchart here. And I'm just going to write down which classes contain the connection with the canvas. Yeah, this is the one of them probably. Pixie color lead. Pixie color lead. Pixie color. Something that I don't understand really well as well, and I don't know how to search for this, is the setters and getters. I understand the concept of setters and getters, but I don't understand how, because it seems like sometimes it does a jump out of nowhere and just calls the getter even though there's not explicit on the code. So I imagine that what's happening is that the compiler at some point, or the interpreter, whatever is interpreting or running the code, at some point under the hood there's something that makes it call the getter and setter, but it's kind of like a black box, and I don't know how to search for this. Maybe I'll ask ChatGPT. But I think it's not that big of a deal, because I just build this stuff on the way that I'm thinking about, so. I think I'll be right back. Or this is the one that has this state. Score lib stats. And what I did to I don't wanna show this stuff. Oh, here. Yeah, this is the function that's... So maybe this is not the one, but it is this one. Oh, it's the same class. There's one of these classes that creates a program which is directly connected, which I think is the program being used to do the drawings. And I want to figure out how... I want to clarify how they build the code on the GSLS code. I think that's how you say it. The language that is gonna... The program that is gonna run inside of the buffer, inside of the GPU. Because I think I want to try to write directly with that language to understand more how it works. Car lib textures. Maybe I should be... I think I made a mistake. I should be putting the systems in the files already. Because even though I have the list here, I'm gonna have to figure out where they are anyway, so... Yeah, but maybe I'll do that now. Let's see which one I have here. So, remove each one. And then I'll look for the other ones that I forgot. Not sure if doing this is a waste of time as well, because it's probably better to just start trying to do stuff. But I think it's probably useful as well to have these things here and to review how it works on each one, because then I have an idea. I think it is kind of necessary, because I need to have a clear picture of how, like, what are all the parts that PixiJS is using, and then exactly how, at what points it connects with the Canvas API, the WebGL API, and then how is building the drawings from using the systems. I think it's probably necessary to do this. think I'm gonna delete these files that are just variations that I'm gonna use, so it doesn't get confusing. Because I'm not gonna use this anyway. Just getting the files that I wanna probably try to incorporate at some point. I think probably the best thing to do is just do what I'm doing now, and after I have all these files that are being used here, then I try to do it from the beginning, and then like for each thing that I'm trying to do, I'm gonna see how it works, and then I'm gonna search on the files that I have from Pixie to see if there are functions that do that. And I think by doing that, I'm gonna understand like how they thought about building the thing, like why they build the functions the way that they did, and like what are the assumptions behind the classes and the construction of the classes. And that's gonna allow me to see if there is stuff that I can remove based on what I'm trying to achieve. Which I think that's probably most 80% probably of the stuff that they have is useless for my use case. Not completely useless, but I think that 80% of the things that there are gonna be a lot of ways to simplify or the stuff that I'm trying to do, and then 20% is probably fundamental. But maybe not. Maybe it's the other way around. do understand how this works as well. And it seems like there isn't anything. It just goes through here and then goes back there, so I don't understand how this works. Maybe I can find where this function is located. Yeah, so I don't get it. Maybe it's not importing from anywhere. Maybe this stuff comes from the browser. I'll ask ChatGPT.
The mystery of life isn't a problem to solve, but a reality to experience.
Yeah, that's what I was thinking about. So it's kind of like document or local storage, stuff like that, where you can use on JavaScript code, but it's defined on the browser, so you can't look at the source code, I think. So it's gonna change depending on what browser the person is using. So I remember that there is the model view projection, and I think that's the way that you construct the visualizations, but I don't remember really well, like what is the, maybe by the name is just easy to think about. The model is just the elements, the view is the view of the canvas, and the projection is the, but I don't know the details of it on how it works. I'll have to study this again and think about it again. I think this is the most annoying thing about these things, is just the coordinate system. Because it's not hard to do it, but it's just annoying to keep thinking about how it's gonna translate everything. And I know that there are libraries, I think GL Matrix is one of them, that do most of the calculations for you, but it's still annoying to have to think about this kind of stuff. Hopefully with time I'm gonna become better, and then I don't have to keep thinking about like the zoom. Figuring out how to make the zoom work was really annoying, because the video from the guy is very good, but the calculations he did was assuming a different coordinate system, I think. So when I tried to implement exactly the way that he was doing, I redid everything, but I did it with like, because the way that I was doing before is different than the way that he did with the variables. So I re-implemented everything with the way that he did, but it still didn't work, because the calculations he was doing was assuming a different coordinate, and then it changes the places you have to divide and multiply, and it's just very annoying figuring out what is the correct way. I think this one I already got. Textures. Yeah, filter system. I'm gonna have to go over again, but next time is gonna be, I'm just gonna skip through most of them, because I didn't grab some of these systems. Discard the render texture. Coordinates. Coordinates. And maybe I should, yeah, I think off stream I will remove probably, because all of them are just duplicated. It's probably the same code, it just changes the extension because of the import system. So I'm gonna leave all of the MJS ones, I think. But it probably doesn't change anything. But I'll do that off stream probably. Oh, there's some systems here as well. I think after 2 hours I'm gonna stop because this is kind of boring to do it. But I have to do it, I think. It's probably better to do this. And then after that I think I'm gonna watch some videos off stream as well. From the guy. Like, try to watch a bunch of videos. And then once I have all the code from Pixie that is actually using on the initialization here, and I watch a couple of lectures and I grab the code for the lecture that I stopped, then I think I can try to incorporate this stuff from the beginning, see and go over all the systems and that kind of stuff to see how to use them. I have to think about... This is what I'm gonna focus on the videos, I think. I'll probably have to go back and forth a bunch of times because like the issue is I don't understand. Maybe I try to build things without Pixie first. Like grab all the code and try to build stuff without Pixie. Just following the tutorials and then using ChatGPT and the API, the documentation for the WebGL API. to do the drawings without anything. Then once I do the drawings, then I go back to Pixie and I try to find, because then I'm gonna remind, so it's gonna be a lot better to know like what kind of things were necessary to do the drawing and what is important, and then I go through Pixie trying to see what parts I think from Pixie are responsible for doing the stuff that I did manually, and then I'm gonna try to do like that, go back and forth. Because obviously if I just try to grab all the code from Pixie and then try to create the visualization with the Pixie code, then I'm not gonna know like what is a good starting point. And what path to go to build this stuff. Core lib geometry. A buffer. This is probably the class that communicates with the GPU, maybe. For most of the tutorials I've seen, it uses these arrays to create a matrix, and then the values of the matrix are gonna dictate what happens, both in the position and the colors. So we just build a bunch of matrices, and then you send through the creator program based on the matrices, and that's the stuff that the GPU is gonna use to calculate everything. So I think this is the class that builds the, like it says here, the data. So. I think I already got this one, so I'm just gonna skip. This one is probably geometry as well, but in another folder, I think. Pixie math lib shapes. Pixie math lib shapes. Pixie math. Probably gonna get all of this. I think I'm gonna get the whole folder. Because it's probably all useful. And obviously this is very intuitive, I think. So it's just classes that build the whatever is necessary to communicate with the buffer to create the shapes. So assume that the systems probably create these classes inside of them to do the drawings on the canvas. In uniform, I think it's just a variable. Core lib shader. Yeah, it's kind of like a global variable in the GLSL language, or something like that. I don't remember really well. It's probably responsible for the colors. Core lib shader. Core lib shader. It's probably all useful as well from this stuff. And I think here is the... Yeah, those are the files that are gonna contain the creation of the program. But I'm just gonna get the ones that are being used there, and I'm gonna try to grab one by one. Because I don't wanna get anything that is not directly being used on the application. I'm pretty sure this shader system is used. Here. Uniform group. I'll be right back. I think it's actually better to leave it like this. Like, the only exception I'm gonna do is the shapes, because then it's gonna force me to think about how to structure everything instead of already copying from Pixie, like the file structure. Pixie events. No, that event boundary is used as well, so. I think all of these are used for the events, if I remember correctly. I'm just gonna pass here. We're just gonna skip these ones. Pixie prepare. And this is the part that starts getting annoying.
If you think about particles, and it turns out that things like position and velocities are not very precisely defined.
I think after I build a simple thing and then I go back and try to see on PixiJS what kind of stuff is useful for the simple stuff that I'm building, I'm going to write down everything that I'm actually using on the application, all the classes. Because if I'm gonna do my own thing and not use PixiJS, then obviously it would be better if I just try to build it in a way that I don't have to refactor the code on my application. I just change the classes and the fundamental logic of the way that everything is set up, but keep the same names and stuff like that. Just trying to trim everything that I'm not going to use and then maintain the core structure and understand more how it works, so I have more flexibility and freedom later on to manipulate the visualizations in the way that I think that is going to be better. So I think once it gets to the point where I'm parsing the code and I'm seeing what kind of stuff, how can I extract the information that I think is going to be useful to help me learn more about the different projects and libraries. Once it gets to that point, I think that there's a lot of things that you can do probably by customizing the visualization, so you're able to maximize the efficiency when you're learning. It's about colors. Colors and putting things in a way that is easier, is intuitive to understand what's going on in the project. And I also think it's very interesting. I think once it gets to the point, start getting very fun to do it. And this beginning stuff is just like the more annoying things. But once it gets to the point where I'm actually translating the code into visualization, that's the part that I think is going to be really interesting. Because then I have like a bunch of different ideas of things you can do. So ideally, I'm going to be able to create a link of the visual representation of code. I want to map out how the code is connected with spacetime. I think that's the end goal, and I think that it's probably going to be a multifractal pattern. So in order to visualize that, it's going to be helpful, I think, to be able to customize the colors and the positions in the way that I want, and it's going to be very difficult, I think. So the more flexibility I have, the better. Because ideally would have a multifractal compressing mechanism where it allows you to map the code based on spacetime in a way that maximizes the efficiency in understanding what's going on. So instead of having to study like each framework, you're able to compress all the information into archetypes, which are patterns over spacetime. And then you create a machine learning model that compresses the information. Based on all the potential, you compress into a multifractal pattern. And maybe that's what already is going on with the large language models and stuff like that. But I don't know enough, so yeah. It's gonna be interesting to build this stuff. I think at that point is the point that starts getting interesting. Right now it's just like the more annoying thing, stuff that it's not very fun to think about. I think it's possible that large language models are conscious already to some degree. Because I was thinking about the other day that the way that emotions work in the human mind, I think, based on stuff that I seen from Andrew Huberman, and it makes sense. I think it's just a weighted average in the same way that machine learning models work, where the weights are the emotions. So the more emotional you are about something, like a traumatic experience, or when you are in a state of ecstasy, you remember much more. So the function of memory is directly correlated with emotion. So the more emotion you have, the more you remember things. And it's like a weighted average. And I think that large language models and machine learning in general is just this mechanism as well, where the weights are the emotions of the large language models. But obviously it might be different because it doesn't correlate, because that's the limits of science. I think it's just a paradox where you can't really determine or say anything about the quality of experience or subjectivity because it's a funnel. And it's always a self-fulfilling prophecy. Yeah, but I think one of the biggest problems I'm gonna have with this stuff that I'm trying to do is that probably the visualizations are going to be extremely complex because I already have experience as well building some stuff, and then there's just a bunch of nodes and you can't really make sense of it. So the challenge is going to be how do you take this very complex thing and you abstract the fundamental patterns, and then from the patterns you're able to increase the speed in which you're able to understand intuitively what's going on in a library. And one of the challenges I think that, and it is one of the main things that I'm thinking about, is that one thing that changes from library to library is just the arbitrary name that people decide to give to variables and functions. And like the core essence of the thing is going to be the same on all of them. So I think you're able to understand the core essence through this multifactorial pattern of thinking, but the problem is that it's not going to translate into actual understanding of how to use the APIs, because you need to know the names of each thing. So I'm gonna have to think about if it's possible or not to create a framework that allows you to use the multifractal way of thinking into becoming more efficient into implementing names. But like this is the problem because you need to know the names anyway. So like what I'm saying is that, let's say for example you analyze several different libraries at the same time and you see that all of them use loops in a certain way and functions in a certain way that are the same, which is software design, just a pattern. It doesn't matter because you still have to know the names of each one. But I think that it might be possible to create like a framework that allows you to, it makes it easier for you to understand, to be able to see the pattern and to see what's fundamental underneath the differences in names, and that it is just arbitrary and just a consequence of the projection of the collective consciousness into the code, because of the nature of symbolic representation that I talked about before, where the binaries become words through the reference frame of the network that attaches meaning to things, because that's what geometry is, I think, and that's what the flow of time is. It's always a self-fulfilling prophecy and a paradox because it's interconnected. The symbols are connected through space and time. The time itself is a byproduct of the relationship between symbols because that's embedded into perception. You can't have distance if you don't have a relativistic notion of the way that symbols connect over time, because that's what a symbol is. Symbol is a reduction of the complexity of infinity that gives the illusion of a boundary between things, which is the nature of geometry. So the approximation of boundaries between things is a multifractal pattern because it's a projection of the frequency of awareness that parses infinity into the structure of space-time. I think I already saw this one. Corley batch. Corley batch. Oh, I didn't get this one. Bash rather. I remember seeing this before. An object render, I'm pretty sure I got it. Yeah, here. I'm just gonna skip. Where does this come from? And this is the code, I think, from GLSL defaults. So I think for this one I'm gonna do the write down the flowchart, because this is the stuff that I'm interested on. I think this is the, like, it is a string that contains the code that is gonna be used on the buffer that the GPU is gonna run to create the visualization. So this is the exact stuff that I'm trying to clarify. So let me think. Batch render. Problem is that, so this comes from this thing. Comes from the plugin system. Here. Maybe for these ones I should create another folder actually. So I remember that they contain the... I'm just gonna leave it like this, the name. Because I want to know what are the classes and files that contain stuff that is going to be directly connected to the JSL. I don't know if this is the name, but the name of the language that communicates with the GPU. So when I'm building stuff from scratch, it's easier to see what is the actual code that they are using to build the visualizations. And it's passing the same stuff. The batch render is the one. I'm just gonna contain the stuff for the state that I remember. Batch renderer. Grab this here. But maybe it's not this one. Or maybe I'm confusing classes. Or don't remember the correct way. This is another thing that I'm thinking about, whether or not it's worth it to think about mobile for now. Because it just adds a bunch of complexity, it's kind of annoying to deal with. And the main point of the stuff that I'm doing, I think, It's not gonna be so much for people that are using mobile, but I know that a bunch of people, like most people, access things through the mobile applications, so. But I think, yeah, it's hard for me to imagine that people will want to visualize code on. It seems like it's much more targeted to people that are using desktop. But I don't know, like. I think I'm definitely on echo chamber, so it's hard for me to know what's going on with most people. And how most people are thinking about stuff. Pixie particle container. Oh. It comes from the plugin. I think this is the class that I was thinking about. And this is probably the same one as before. No particle. And particle. MJS. Do I think I have to do the same thing for the thing. The same that I did for this one. So this class, I think I've seen it before, but maybe not. This car lib shader. I think I got this class already. So I think it's the same paradigm that they do with the other stuff, where probably this class is the base one, and then the other classes add more functionality to specialize for each thing. So they have some core classes that are base classes for everything else, and then each part of the thing specializes. And I think it's probably the same paradigm with all or most object-oriented programming stuff. It's just gonna be the same thing because it is mapping the structure of space-time. And I think it's very likely that things are like that, where... And this is the reason why you have the gradient as well, because that's also part of the structure of space-time. The gradient between object-oriented programming and composition. And it depends on the stuff that you are trying to do, but then that's the challenge, is trying to clarify when exactly is better to use one over the other. And there's the part that is fundamental, and then there's the part that is a consequence of the way that people think at each moment in time, and is a result of this cycle, of this spiral, of the nature of the flow of information. Oh, I didn't get this one, so maybe it was one similar to this one. But I think I'm gonna leave this one together with these others, ones that contain the string. This is the one that I was remembering that is directly connected with the WebGL language. Yeah, that's the one. And then it's gonna use this one probably, which is the program, passing the vertex that got from the other class, which are these ones here. And that creates the program, and then creates a new shader, which is this class here, which has the program and the uniforms. So I think this is the one that is going to be the base, that is going to construct everything. And then this path here contains probably all the classes that contain the string, which are the base templates for the WebGL language. And then it's going to use all of that to build the programs, and the other classes are going to manage everything else. Things are becoming more clear in my mind how it works. So probably the ones that I'm going to use the most are the files located in this path here. Yeah, but the thing is that the other one is on another place. So maybe I'll have to go back and see what path is this one, because I didn't wrote down. Oh, here. Yeah, I needed to write down where the point is. I'll probably go back and get the point. So I have to figure out where are all the files that contain the main base strings that have the code. And also the ones that are the base classes for using the code to build the stuff. Shader program, so is this one. I'm probably gonna, yeah, I think I'm just gonna copy all of them because they're probably all, they are the base classes for the... Maybe I should separate this into files. I think I'm gonna do that. I'll put program here. Because that way I separate the classes that are related to the creating the program, and the files that contain the strings for the actual code. I think I'm gonna copy this stuff as well. It's probably all useful. Oh, here. I think I'm gonna stop here. I'm gonna go back and get the systems that I didn't get from here. Like go restart all this process of looping over all this stuff and then get this remaining systems here and the functions that they use. I think I'm not gonna step over the context change and the init because it's just gonna be annoying and it's probably a waste of time because I don't need to know all of the stuff that is used. I think all the ones that I got already, I need to figure out the path, this path here of the dot here. So I assume that most of the code that is going to be actually used comes from this path here and this one. So all I have to do is get those files and then I already have all the files for the programs, I think. And those are the fundamental ones that are directly connected with WebGL. And I think if there are other ones, it's probably not that much like more. So it's not worth spending a bunch of time stepping over the context change, and maybe the context change is actually useful because I have to understand how they manage the context. I think that's very important, but it's kind of annoying. So maybe next time I'll do that. I'm just gonna watch the videos off stream and then next time I'll step over the context change for like this part here. After he calls the init, then it's gonna call after he calls the init here on this one context system, is gonna call the context change for these systems here. So I think I'll have to go, or maybe I'll just get, yeah, because the name of this is oh, these are the systems here. I think that's a better idea. I just go with the files I already have. I'm gonna have all the systems. I just go through the files here and then I look at the source code for and see if there's anything that might potentially be related to the shaders. And also, I think just by going over the files manually through the source code and not having to step through them, I'm gonna understand how, if there's anything that, like how in the general sense they are managing the state. So if I wasn't using all the separate classes and I just put all the code together, or how much I would be able to remove just to keep the essence of managing the context for the WebGL. That's one of the main things, and the other thing is how does it decide which renderer to use. But that one I think I'm not going to be able to figure out because I would have to spend a bunch of time trying to understand the extensions and how does it do in the beginning there, like the code that's very annoying and weird to think about, of how it puts everything on the extensions and then it selects the renderer based on that. I think I can just copy the renderer class, and then I can probably use ChatGPT and watch other tutorials or search online on how to create a system that defaults to the normal canvas if there isn't a WebGL. The browser doesn't have WebGL. The challenge with that is how to make sense of, because they probably have a bunch of other classes that handle normal canvas stuff. Because if it doesn't have a WebGL, then it should be able to do everything that it does with WebGL, but with the normal canvas. And this will be very annoying, I think. But I'm not sure, not sure if it's worth spending time trying to figure that out. That's the part that I think is gonna be the most difficult. So, not really sure. Yeah, I think it's probably better to just focus on the WebGL stuff and then just do a simple solution, like maybe not allow for normal canvas and just allow browsers that have WebGL or something like that. Or maybe after I have a good understanding of how WebGL works, how the classes work, and I finish building all this stuff on my own for WebGL, then I can go back and... Because obviously there's going to be a difference on the APIs, I think. So the way that it works is that you have the API for the WebGL and Canvas that comes from the browser, and then you have the classes on Pixie that are directly connected with the API and that build the code. And then the WebGL one is going to use the shaders and fragments, and the normal Canvas is not going to use that, and it's going to be something different. So at that step, they're going to deviate a bunch, and then there's probably going to be other classes that are specialized for each one. This one I think I already got. PixiJS lib shader. PixiJS lib shader, yeah. Farm group. Here. So I think probably the best approach is from now. Particle renderer already got. Try to get all the files that are running, go over all the systems that I forgot to get here, then manually go to the source code directly instead of stepping through it. For the systems that have the context change, see if inside of the context change there is anything that is going to be interesting, and try to extract only the stuff that is fundamental to handle the context of the WebGL Canvas. And then after that I will watch some of these videos here, and then whatever place I stop, I think I'm gonna get the code and copy the code that he provides here in this other folder, the learning folder. And then with the code that I get from the tutorials and the code from Pixie, I'm gonna go back and forth between the two until I understand how, like, what are the choices that they made on PixiJS to build this stuff. So I'm gonna understand how they thought about constructing the whole thing. And then after that, then I think about how to choose the context and things like that for defaulting to the normal canvas. And after that, I'm gonna think about if I can construct the stuff in a way that is not gonna require me to refactor the code too much on the main application. I can just replace the Pixie library with my own custom code and see if it works. That's the goal. And then if I can do everything with my own code, then I think I'm not going to use Pixie, I'm just going to use my own code. That allows me to have a lot more flexibility on the way that I build the visualization. Then at that point, I will start thinking about how to create a component to customize everything, and then change the CSS of the whole website, then deploy with Vite instead of Next.js. And then from that point, then I can start finally studying the interpreters and compilers to see how I'm gonna extract the important information from code and create a visualization. So tomorrow probably I'm gonna start from hopefully from the place where I already have the code from the guy, and I'm gonna try to do this other stuff off string now. So I'm not sure if I'm gonna come back tomorrow. Maybe I will do some of this stuff off stream as well. But next time I'm probably gonna continue to work on this. So